Hi students, this is Naveen. Today we are going to solve one more PYQ from capacitors concept. Let's solve the problem. A capacitor is made of two square plates, each of side A, making a very small angle alpha between them as shown in figure. The capacitance will be closer to. First of all, the capacitor having two plates. These are the two plates of the capacitor. Now what is the condition given? The plate of the capacitor making an angle here. Let us consider it is making an angle alpha. Let us consider the alpha is very small. Now we have to find out the capacitance of these two plates. How to find out the capacitance of those two plates? How to find out means, first of all we have to consider one element of those two capacitors. After that you have to find out the capacitance of that element. After that you have to integrate the capacitance of that element. We will finally get the capacitance of the given plates. First of all, let us consider an element here. Let us consider a small element here. Small element. I will consider a small element here. The width of the element dx. The element I will consider at a distance of x. It is clear. Now we have to find out the capacitance of this element. How to find out the capacitance of this element? We know that C is equal to, what is the formula? Epsilon naught A by D. For that, before that you have to know what is the distance between these two plates? D. Let us consider the distance between those two plates D. Nothing but here to here. What is the distance here? D. And plates each of side A, nothing but here the side length of the plate is A. Now C is equal to epsilon naught. See, if you want to find out the capacitance of element, it will become DC. DC is equal to epsilon naught area. Area is equal to this is the width into here. This is the square plate. Square plate means all sides are same. This is A and this is A. Area is equal to, this one is also A. A multiplied with dx. Area is equal to A dx by, what is the distance here? From here to here distance D, but here to here we have to find out the remaining distance. Let us assume from here to here I will assume that is y. Now how to find out the y value? If you observe, it is in the form of right angle triangle. I can draw here. This is the right angle triangle. Here, this is alpha and this is y and this is x. From this, how to write? Tan alpha is equal to y by x. From this, what is our requirement? We have to find out the y. Y is equal to x tan alpha. Just substitute the total distance here. D plus x tan alpha. This is the capacitance of given element. But we have to find out capacitance of those two plates. For that, I have to integrate on both sides of this equation. It will become integral 0 to c dc, that is equal to epsilon naught A dx by D plus x tan alpha. I have to integrate both sides, means from here also I will write 0 to, from the starting point x is equal to 0, 0 to, what is the length of this side? A. I will write x is equal to 0 to x is equal to A. 0 to A multiplied with epsilon naught A dx by D plus x tan alpha. Now if you integrate this one, it will become C. And from here, epsilon naught is a constant value, A is the constant. Remaining integral 0 to A. What are the remaining terms here? Dx by D plus x observe, if you consider the total term d plus x tan alpha, it is total term consider the x, how it will look like? Integral 1 by x dx. What is the integral 1 by x dx value? Integral 1 by x dx is equal to ln of x. How to write this equation? This equation becomes, here x is multiplied with tan alpha, this equation becomes epsilon naught a. X is multiplied with tan alpha means here I will write tan alpha multiplied with ln of, what is the x here? D plus x tan alpha. I have to apply limit here 0 to a. Here we can utilize the formula integral 1 by x dx is equal to ln of x. It is clear. Now if you observe the alpha they are given, the angle alpha is very small. Here if angle alpha is very small means tan alpha becomes alpha. In which condition? If alpha is very small. If alpha is very small means tan alpha is equal to alpha. From this how can I write? C is equal to epsilon naught a by, it will become alpha ln of d plus x alpha. What are the limits here? 0 to a. Now we have to apply the limits here. C is equal to epsilon naught a by alpha ln of, first of all I have to apply the a instead of x, ln of, what is this one? This is d plus a alpha minus, what is the 0 I have to apply instead of x, ln of x alpha becomes 0, ln of d. It is clear. If you observe, it is in the form of log a minus log b. It is also written as c is equal to epsilon naught a by alpha. I can also written as ln of, what is the a here? D plus a alpha by d. Now we have to simplify this one also. Till now it is clear. We have to use this formula c is equal to epsilon naught a by d. By that we are able to find out the DC, nothing but this is the capacitance of the given element. We are getting DC is equal to epsilon naught a dx by d plus x tan alpha. Here a dx is the area, here dx, and this side will be a, and because that is a square plate. And next one, by using this we finally got c is equal to epsilon naught a by alpha multiplied with ln of d plus a alpha by d. Now we are going to simplify that one also. C is equal to epsilon naught a by alpha. How to write this one? Ln of d plus alpha by t. Is there any common terms here? I can write ln of 1 plus a alpha by d. If you observe, it is in the form of ln of 1 plus x. What is the ln of 1 plus x value? X minus x square by 2. I don't want to expand this equation because here alpha is very small. Just apply this equation. C is equal to epsilon naught a by alpha ln of 1 plus x means how can I write x? X means a alpha by d minus a square alpha square by d square by 2. It is clear. From this, C is equal to epsilon naught a by alpha by d minus a square alpha square. It will become a square alpha square by d square into 1 by 2. It will become 2d square. Till now it is clear. From this, C is equal to epsilon naught a by alpha. Here if I take A alpha by D common, 1 minus A alpha by 2D. Now if you observe, alpha alpha both are cancelled to each other. From this C is equal to epsilon naught A square by D multiplied with 1 minus A alpha by 2D. This is the final answer. This is the capacitance of the given capacitor, which is having 2 square plates. Like this, you have to find out the capacitance of the given capacitor. First, you have to find out the element capacitance. After that, you have to integrate. It is clear? Thank you. Thank you all of you.